So good day viewers, welcome to another mathematics presentation. So in this presentation, I want us to look at the index notation. We are going to answer questions that are coming from different past exam papers. So we have our question right here. Evaluate the following. So we have our question 1. We need to evaluate 3 over 2 in brackets raised to the power of a negative 2. Okay, so we're going to start with the first one. So here we are going to write the solutions. So let me just make a demarcation here. We are going to have solutions this side. So our first question is our question 1, which is in brackets we have 3 over 2 raised to the power of a negative 2. So we need to evaluate this. Okay, so how can we evaluate this? We take a look at the power. The power is having a negative 2 right here, and the base is a fraction 3 over 2. So to evaluate this, we are going to write it like this. So because the power is having a negative 2, we need to find the reciprocal of this base, which is going to be 2 over 3. Okay, in brackets. Then this power is going to be a positive what? Power. Okay, so since we had the negative power, we have just found the reciprocal of the base 3 over 2, which is 2 over 3. Then this one will have a positive power. So from here, now we have 3 over 2 in brackets to the power 2. This means the same base 2 over 3 has been multiplied by itself twice. Okay, and this can be written like this. You can write it like this, 3. You can say 2 over 3 again times 2 over 3. Okay, so from here, 2 times 2, it's a 4. 3 times 3, it's a 9. So this is our final answer. So we have answered our question 1. We now come to our second question right here. So our second question is 5 raised to the power of 3 times 1 over 5 raised to the power of 2. So how can we work out this one? So to work out this one, there are many methods that we can use. Okay, we can say 5 to the power 3 times 1. Okay, so we have 5 to the power 3 means we multiply the base by itself 3 times. So we're going to have 5 times 5 times 5. Again times 1 over 5 power 2 means we multiply the base 5 by itself twice. So this will be written as 5 times 5. Then from here, we can cancel this 5 and this 5. We can also cancel this 5 and this 5. We're having 1, 1, even here 1, 1. So what we have here is we have 5 times 1 times 1 times 1, which will give us a 5, over 1 times 1, it's a 1. 1 into 5, the answer is a what? A 5. So this is our final answer. There is another method that you can use when you multiply 5 power 3 times 1 to give you 5 power 3 over 5 power 2, of which you can apply the laws of what? Indices. Okay, so we can continue. We are just from answering our second question. Let us now look at our third question. Okay. All right, so this is our third question. We need to evaluate 9 to the power half plus 1. So before we evaluate this one, we need to take something into consideration. If you have something like the square root of a, this can be written as you can write this as a to the power half. So this square root, it's 1 over 2. So the same thing can apply if you have the square root of 9. You can write this as 9 to the power 1 over 2. This is the 9 to the power 1 over 2 you are seeing, because this half can be written using this radical, a root, which is the square root. Okay, so I'll use two methods that to answer this question. So I'll write 9 to the power half with a square root of 9, then plus 1. So the square root of 9, we are looking for the number that we can multiply by itself twice to get 9. That number is a 3. So the square root of 9 is a 3 plus 1. And this will give us a 4. This is our first method. The second method that you can use, you have 9 to the power 1 over 2 plus 1. So we know that if you have 9, This 9 can be written in index form because 9 is a perfect square. So I can write as 3 to the power 2. Because 3 to the power 2 means 3 times 3, 3 times 3, which will definitely give us a what? A 9, okay? So we are going to write this 9 to index form, which will be 3 power 2, then to the power 1 over 2, then plus 1. So we can cancel here, we apply power of the power principle. We can cancel this 2 and this 2, remain with 3 plus 1, because we had 3 to the power 1, 3 to the power 1 is the same number 3. So 3 plus 1, this will give us 4. So you can either use this method or this one. So we are done answering our third question. Let us now answer our last question. Alright, so we are now answering our question 4 right here. So we need to evaluate. In brackets we have 64 over 125 raised to the power of negative 1 over 3. So if you remember with the first question where we have a negative power, we need to find the reciprocal of this base, which is a fraction. So this one we are going to write it 125 over 64. In brackets, raised to the power 1/3. So the negative has gone here because I found the reciprocal of this base. Okay. Then from here, 1 over 3, it's a root of which it's a third root. So this root is affecting both the numerator and the denominator. So we are going to have the third root of 125 over 64. This is what it means. So I've just gotten this. Okay, this is what you are going to have. So now the third root of 125, we are looking for the number that you can multiply by itself 3 times to get 125. So the third root of 125, it's a 5 over the third root of 64, it's a 4. So we have 5 over 4. So we can leave this as a mixed fraction where we say 4 into 5, it's 1, remainder 1 over 4. So this is our final answer. So thank you so much everybody for having time to view this content. This has been your presenter, Mr. Mlenga. Bye bye.